Good evening, everybody, and welcome to this National Astronomy Week event. My name is Dr. Stephen Wilkins, and I'm tonight's chair. So this event tonight is a live panel question and answer session with a particular focus both on life in the universe and careers in space science. As I said, my name is Dr. Stephen Wilkins. I am the head of astronomy at the University of Sussex. I don't actually work on life in the universe myself. I'm actually an extragalactic astronomer. So I study very distant stars and very distant stars and galaxies. Just in terms of the format tonight, if you have questions, then please use the question and answer feature built into Zoom. So if you type in questions there, they'll then appear on my screen, and I will read out all of the questions to our panel tonight. To get us going, I'm going to ask the panel to all introduce themselves, hopefully going in alphabetical order. So can we start with you, Jo?
Good evening, everybody. I'm Dr. Jo Barstow. I am a planetary scientist and astronomer working in the field of extrasolar planets, and I am currently an Ernest Rutherford Fellow at the Open University.
Thank you, Jo. Jane?
Hi, everybody. I'm Jane Grieves. I work at Cardiff University. I would, I guess, call myself a radio astronomer and astrobiologist, which is a pretty unusual combination. But I'm interested in life in the universe and where planets come from, but also a bit about possibilities for life elsewhere in our own solar system.
Thanks, Jane. Naomi?
Hi, I'm Naomi Rogers, and I'm a PhD student at the University of Leicester. I'm in my final year, and the subject of my thesis is the ice giants Uranus and Neptune, especially their atmospheres, and looking at them using something called the Spitzer Space Telescope. So I'm kind of an astronomer and also a planetary scientist.
Thank you, Naomi. Clara?
Hi everyone, I'm Dr. Clara Souza Silva. I'm a quantum astrochemist at Harvard, and I study how molecules interact with light. And my main focus is looking for molecules that may be associated with life. My favorite, in case anyone's wondering, is phosphine.
Thank you, Clara. And finally, Elizabeth.
Hello, I'm Dr. Elizabeth Stanway. I am at the University of Warwick, and I am an extragalactic astronomer studying stellar populations across the universe. As part of that, I look at how stars end their lives and the impact that supernovae and similar energetic events may have on the habitability within galaxies.
Thank you, Elizabeth. So just to recap, please do put your questions into the question and answer scheme. These can be on anything to do with life, but also on careers in astronomy and space science. We'll try and answer as many questions as we can. I've got a few warm-up questions just to start off with while we're waiting for a few questions from the audience. So my first one, which I'm going to ask to all of the panel, is with regards to life, what is the thing that you're really looking forward to in the next 10 years? What do you think we're going to learn in the next 10 years?
So what I'm looking forward to is the James Webb Space Telescope, which is going to launch in about a year's time, spotting some chemical in the atmosphere of an exoplanet that suggests not necessarily that there's life there, but at least that it might be a little bit like the Earth. So one of the things I'm quite excited about is the possibility that it might be able to detect ozone in the atmosphere of a rocky exoplanet.
Thanks, Jo. Hopefully people can still hear me, but I think my Zoom has just frozen. Jane, if you can still hear me?
Yes, I can hear you. I guess for the next 10 years, I'm hoping that some of the rovers and other experiments we've got going in the solar system might find something that's not just a hint of life, but like a really strong piece of evidence. Maybe that's ambitious for the next 10 years, but that would be fantastic.
I'm actually also really excited about the James Webb Space Telescope, but I'm also super excited about the missions that are going to icy moons, because I feel like we're going to find something under the ice in those subsurface oceans. Really exciting.
I'm excited about a lot of things, but I'm worried that a lot of the instruments we're going to get are going to point at really cool planets, and we're not going to have the tools to interpret them. So what I'm really excited about is trying to convince enough junior people and enough kids to join the field of, well, quantum astrochemistry, I suppose, and learn what all the molecules look like so that we will know life when we see it.
Elizabeth?
I would echo a lot of what's already been said in terms of the exciting possibility of seeing signatures of life in distant planet atmospheres. I'd also point out that over the next 5 to 10 years, there are a number of missions that will be launching that will search for rocky planets around an increasingly large number of stars. Many of those could be bright enough to be accessible to spectroscopy to look for these biosignatures. And this is an exciting possibility as we move into the future.
Thank you, Elizabeth. I'm just going to ask another question to all the members of the panel now, and I'm going to take it in reverse order. So I'll begin with you, Elizabeth. So what inspired you to become an astronomer or planetary scientist, or in fact, quantum astrochemist, Clara? So
Well,
Elizabeth?
I'm very much an astronomer. In fact, these days I'm increasingly a theoretical astrophysicist as well as an observational one. What really inspired me was the big questions that there were out there to answer, and the excitement of being able to look up at the sky and really wonder about what was going on there. I have to say, because I'm also a science fiction fan and have a strong interest in the science in science fiction, that being exposed to that at an early age helped to put those questions into my mind and to get me thinking about the possibilities that I now explore as an astronomer.
Thank you, Elizabeth. Clara?
I think what got me into quantum astrochemistry was the realization that to answer these really big, almost philosophical questions of, is there life on that planet? Are we alone? You have to use the tiniest possible tools. And that just seemed so cool to me and so powerful that I wanted to do it. So that's my goal, to use the tiniest things to explain the biggest problems.
Thank you, Clara. Naomi?
I was definitely inspired by, I went on a school trip when I was a kid to a planetarium, and just seeing like the scale of the universe and how many questions were still unanswered was really like a light bulb going on in my brain to say, like, wow, there's still stuff that we don't know. Because when you're a kid, you think that we know everything. So that was definitely what put me down the path of curiosity into science.
Thanks, Naomi. Jane?
Yeah, definitely science fiction for me. When I was about 12, I read A Fall of Moon Dust by Arthur C. Clarke. And one of the two leading characters is a very grumpy infrared astronomer who works on the moon. And I think I just identified with that. So I think I've achieved the first two. I'm a grumpy infrared astronomer, and it's just the working on the moon bit that's still to go.
And Jo?
I was in the middle of my A-levels, and I got a Nuffield bursary to go and work at the University of Leicester during the summer. And I worked with part of the team that designed one of the instruments for the Beagle 2 Mars lander. So some of you may be too young to really remember that. This was a lander that the UK launched to Mars. Sadly, it didn't work. But I had a fantastic time that summer trying to work out what that instrument would have been able to tell us. And after that, there was nothing else that I wanted to do apart from study planets. That was it.
Thanks, Jo. And actually, that's a great segue into one of our questions. So from Ishani, asks, who is going to be doing her GCSEs in summer 2021. They ask, what sort of work experience could you potentially get in astronomy or planetary science, and what would be the best way of getting it? Jo, do you think you could have a go at answering that question, given what you've just said?
Well, I believe that those bursaries do still exist. I'm not sure if they're necessarily called the same thing, but it is possible. So this is a nationwide scheme in the UK that enables you to spend a few weeks of your summer holiday in the middle of your A-level years, working in some scientific field. So the organisation partners with various universities, also I think with industrial partners as well. And I think, I assume it's still the same, we got a sort of nominal amount of money for doing so. So it also wasn't an unpaid internship. So that's definitely something that's worth looking into. So the Nuffield Bursary scheme is what it used to be called. It may still be the same.
Thanks, Joe. I think, Clara, you have a scheme that you're involved in as well here.
I'm actually not involved anymore. Other better people have taken over, but there's a program called Orbits, or Original Research by Young Twinkle Students, that is associated with the Twinkle Space mission, but they connect young scientists to secondary school students, so just after your GCSEs, during your A-levels, and help you do original research towards kind of publication even. So you should find out if there's any near your area that you could participate in. It's a very cool program. I think we have over 100 kids now producing publishable research in astrophysics.
So that, Clara. Just to mention a couple of schemes I'm aware of, there are, for example, IRIS, which is the Institute for Research in Schools. I think most of that is quite structured, so it's something that you would do as part of your schoolwork. And obviously you can contact your local university or research institute who might be able to help you as well. Okay, looking at a science question now. If we discovered life in the solar system, for example, in one of the moons of Jupiter or Saturn, should we investigate it with a robotic probe? Naomi, do you want to answer this one?
Sure. I think that we should, yes, because we want to answer questions, but also we need to be really careful not to bring anything back with us or take anything there, because if there's the possibility of a life, there's also the possibility that we will contaminate that life or kill that life. Yeah, that could be, the movie Life, where they get the thing on the on the spacecraft and everybody dies. So yeah, we don't want any of that to happen.
That's great. Jane, would you like to answer this question as well?
Yeah, it's a fascinating question. So obviously we don't want to interfere with life that is in perhaps a very fragile habitat, or even, let it do something bad to us. But I think the prospects for sending exploration to Europa and maybe Enceladus, and there's one or two of the other moons as well that have these sub-ice oceans or lakes, and some of that stuff escapes. So I think there are possibilities for safely probing. In a lot of the cases where we think there could be some possibility of a different origin of life there. So it's a source with energy. If it's a moon with kind of heating through tides or some trapped radioactivity or something, there is some prospect of an independent genesis of life, as it's called. But situations a bit analogous to life on the seafloor, which is very different, life on our seafloor here, to what we see on the surface of the Earth. So there's, giant tube worms and all sorts of stuff in these very small habitats powered by one kind of lava crack, leaching heat out of the core of the Earth. So that is very exciting. And particularly on the moons that have these cracks in the ice, I think there are possibilities maybe for some kind of rover to at least crawl up to the edge of the crack and sample the gas and the water coming out, and might even, find molecules that are really you couldn't explain from just some kind of chemistry in cold water, but something out of equilibrium that might require a little organism there. So I think it's very exciting. We've done a bit of work, including my team, with radio telescopes. You can look with telescopes on the Earth for some of these gases coming out of these moons as well. So, it's something we might be a bit more prepped for by the time we can get a mission like Europa Clipper out there.
We've got a question here about Astronomy Careers, which I might try and answer myself. So the question is it possible to move into astronomy as a career when you're older? So what advice would you give to someone over 40 with no science qualifications thinking of a career change? The reason why I was interested in answering this is at my university, the University of Sussex, we actually have several students who have taken career paths like that, who have had basically moving into a second career now. I've had a almost entirely full career in a different field and have decided to make the transition. So it really depends on what kind of level of experience that you come in with. So if you already have a undergraduate degree in something allied to astronomy, this could be mathematics or physics or even computer science, there is the possibility of a direct entry into a PhD. Even in those cases, you might like to refresh your knowledge by doing, for an example, a master's program. So there's several master's programs across the UK, many of which kind of build you up from a relatively introductory level. And they're a great way of then moving on to doing a PhD. If you're really coming in with no science experience at all, then obviously the first step is to investigate doing an undergraduate degree. And obviously going through something like the Open University is a great way of doing that, because you can learn remotely and you can fit it around any work commitments that you have. Hopefully I've caught a lot of things there, but does anybody else have anything else they'd like to add on that question?
I was just going to add, I did one of the Open University's free courses. They have these great short courses that, you know, you don't require any knowledge to go into. And I'm interested in planets, so I did their 15-hour course on plate tectonics. I'm partway through. I think I know a lot more about how planets work now. And yeah, it was just really fun experience. And you can do all those tasters and see what kind of science area you're most intrigued by, I think.
Definitely like to agree with Steve about Open University. That's where I teach now. So that would be a great avenue. If you're not quite sure about whether or not you might want to do this, then a course that's not currently running but should be relaunched quite soon is the Certificate in Astronomy course at University College London, which is something that I used to teach. It's a 2-year evening course. It's a great introduction to astronomy, and it's equivalent to first year of a degree. I know several previous students that have gone on to do master's work and also postgraduate work. So that's a really good introduction as well, if that's what you're looking for.
Thanks, Joe. I think, Elizabeth, do you have something to add to this as well?
Yes, I just wanted to mention that modern telescopes and projects are huge operations. They involve engineering, construction, they involve software, they also involve public communication and outreach. And so if academic pathways may not be best suited to your interest or skill set, there may be alternative pathways which would still bring you up to the cutting edge of science and interacting with those who are doing the more technical and academic side of the work, while being able to communicate and engage and contribute to that career.
Thanks, Elizabeth, that's great. And I think the original question answer also mentioned that they have a law degree. I would just say that I think there is a growing need for that intersection between people understanding space and astronomy and being interested in it and a law degree, and subjects like that. As we continue to commercialize space, we are going to run into legal issues in the future. So there might even be the opportunity for you to kind of merge your interests together, which is a great one. On a completely
Even if I may add, if I may add, one of the things I wanted to say for people who may not want to do an academic path is, specifically, I find it much easier to teach astronomy to people who can code than to teach programming to people who know astronomy. And so if you don't want to do one of these courses, though these are all excellent suggestions, if you would like to learn programming, they'll be useful for a lot of applications, but it would certainly be wonderful to have a coder who can come and help astronomers through their usually, no offense to anyone on this call, I'm speaking for myself, the usual clunky code. So yes, that's the other way of avoiding a formal education, still being extremely useful in astronomy.
Yeah, that's definitely an excellent point, given how much we rely on computational skills these days. So a completely different question is coming from Hannah, who asks, what would be the best type of telescope to have at home for a 10-year-old? Does anybody want to have a go at answering this? I'm going to pick on Joe.
I'm very sorry, I really don't know. Not having yet a 10-year-old and not possessing a telescope, I'm completely the wrong person to answer that.
I think Elizabeth was going to try and answer as well, is that right?
Well, I was going to suggest that that's a question that could also be raised with our practical astronomers who will be coming online in about 40 minutes. So if you stay on at the end of this session. All I was going to add to that was that modern home telescopes are actually really quite advanced bits of kit, which are now capable of finding the objects you're interested in on the sky. but really the best people to talk to are those astronomers who do this in their own time with small scale equipment that's likely to be comparable to what you use. And whether you can able to stay on later, or whether you can contact your local amateur astronomy society, either of those is a good approach.
That's great, thank you, Elizabeth. And just to add to that, yes, the amateur astronomy societies, there are many of these across the country, and they're a great source of knowledge. Obviously, in the current situation, you might not be able to see people face to face. Another excellent resource is there is a astronomy group called, I believe it's UK Astronomy, which is a mostly amateur community, and that's really very much focused on helping people buy telescopes and pointing them in the right directions. And just to add one last thing there, you don't even need a telescope. You can, if you go to a nice dark sky, a dark site, you can see the Milky Way with your own eyes, which is an amazing experience. And if you want to go a bit further, but still be on a very small budget, you could buy a good pair of binoculars, which will get you started. And you could kind of take a gradual or incremental approach.
There was a question on YouTube about the women in the panel and whether there were opportunities for independent fellowships for advanced studies in astronomy, specifically for women. I should say that it is unusual to get a panel entirely made of women in astronomy, but it is an indication that in an exciting area like this, there are opportunities which are open to all, and the community is increasingly trying to reach out and engage with all of the different communities and individuals who could contribute. In terms of advanced fellowships for women, we should mention that there is an initiative from the L'Oreal company who sponsor L'Oreal fellowships. There are also a number of fellowships aimed at those for whom their identity or situation may have hindered their studies in the past, which could contribute to returning. But those kind of opportunities are generally quite well advertised within the community. A good opportunity to a good approach is to talk to existing people within the community on a one-to-one level, who will then be able to advise you.
Next question. This one's directed at Clara specifically, and the anonymous question asker asks, do you take pride in telling people about your job title? It contains 3 of the coolest words out there. I'm not sure if that's a question or just a comment on your job title, Clara, but I'll let you respond to it.
Yeah, I take enormous pride in my job title because, as you pointed out, it is super cool. But I should point out, in case anyone's wondering, it's not exactly an established field. I don't think it entirely exists beyond myself and a few colleagues. So, you know, please join us. You can get to the top of the field very quickly. You just need to overcome me, I think, which will be easy. I'm really a mediocre quantum astrochemist. So yes, I take enormous pride, and it is very cool. And I'll take this opportunity to actually answer another question that someone mentioned, which is, how do you become one? What kind of A-levels you have to take? You may think you have to take chemistry A-levels, and I think that would be really nice, but you should know I didn't. I got into a fight with my chemistry teacher and quit that A-level. So I ended up just doing physics, and I learned quantum physics in undergrad, and that's what got me the skills I needed to learn quantum chemistry and apply that to astronomy, becoming an astrochemist. So there's really no exact way. Do the science you like, and you probably will be able to apply it somewhere to quantum chemistry.
Thank you very much, Clara. So there's many questions coming in now. I'm going to jump to a more science-focused question now, and this one's from Jeff, who asks, thousands of exoplanets have now been detected so far, and there must surely be billions. What are your estimates for the abundance of life in the galaxy? I think I'm going to pick on Joe to begin that one.
I think it depends what you mean by life. I suspect that primitive life of the kind that we have on Earth in the form of bacteria, things like tardigrades, those little water bears, things like that might not look exactly like the ones here, but are similarly sort of primitive and basic. I suspect they're pretty much everywhere in most systems. I think it's likely. In terms of evolved and intelligent life, I'm a lot more skeptical. And part of that is because of something called the Fermi Paradox, which you might have heard of, which basically says, if life is easy to make, if life is out there and it's abundant, then where is it? Why aren't we hearing from it? Because there are many planetary systems that are much older than ours, that have had much longer to evolve. And we're just getting to the point where we're starting to broadcast our presence into space. We're using radio waves, and if anyone is watching, they would be starting to get a good idea that there's something unusual going on this planet. So if that's the case, where on earth are all of the radio signals from other civilizations? The fact that we haven't seen any implies that either they're being very, very, very quiet about it, or they're not there at all.
Thanks, Joe. I know, Elizabeth, this is something that you have an interest in. Do you have any extra thoughts?
In terms of why we don't see alien life already, or where they could all be hiding, it's difficult to say. I mean, there are a number of circumstances about the Earth and the solar system, its very large moon, its axial tilt, all of which might mean that we are in an unusual situation. Another area which, as Steve knows, I work on and I'm quite fond of, is cosmic catastrophism, how easy it is to wipe out life with supernovae and gamma ray bursts. And it's probably slightly disturbing the way my eyes light up when I talk about wiping out entire civilizations. But it is nonetheless true that a large fraction of the universe is likely to be irradiated by supernovae, gamma ray bursts, active galactic nuclei, collisions between galaxies which have occurred in the past, could all have led to large regions of space being sterilized in the past. Having said that, it still doesn't resolve the Fermi Paradox and why we don't see anything in our own Milky Way where there are unlikely to have been substantial fractions affected by such events.
Thanks, Elizabeth. And Clara, would you like to mention something?
Yeah, just something minor perhaps, which is I think people worry a lot, as I do, about finding intelligent life, but it's really not a particularly common life form on Earth. And the kind of signals that it sends are extremely recent. But otherwise, there's a lot of averageness around. You know, the molecular cloud that formed the solar system was pretty average. Our sun is deeply average. Rocky planets are very mediocre. They're the most common planet type. And so there's a lot of averageness to our current circumstances. And so to think that then at some point, amidst all this averageness, we are so special that it only happened here is probably a mathematical implausibility. And so life, intelligent life, I don't want to comment on because there are people on this panel that can do so much more eloquently and have done so. But life at all is likely inevitable given some set of circumstances. And there's no reason to think that we are special. So that's the reminder. We're average. All of us are average, and the planet is too. So we should find life as a mediocre event throughout the galaxy.
Thanks, Clara. That's great. We have a question which is directed at Naomi here. So if you had to choose one, would you send a spacecraft to Uranus or Neptune?
Oh, I love this question. Well, preferably both, and that's the problem at the moment. I think a lot of scientists want to send both, so there's not enough money to do that because it takes a lot of money to get all the way out to Uranus and Neptune. I probably would choose Uranus because it's weird. It's like tilted on its side and it's colder than it should be. And we just don't understand what's going on at Uranus. But then on the other hand, Neptune is our like typical ice giant, the one that we're kind of most interested in because it resembles planets that we might see in other solar systems. So it's difficult. It's literally personal preference that I like Uranus because it's weird.
Thanks, Naomi. That's great. And I think I agree with you there. Although Neptune does look a little bit cooler. Looks like it's got more features.
It does. It has a better color, right?
Yeah, it does. I'm glad you agree. Great, thank you. So this is a question that I'm going to ask to all of the panel members, and I'm going to try and answer it myself as well. And this asks from an anonymous attendee, how does your typical day at work look like? So I'm going to use my chair's privilege and answer this one first. So as an academic, I mix teaching, administration, and research. And so today I spent 2 hours teaching. 1 hour of that was actually face-to-face and 1 hour on Zoom. And then I spent around 2 hours answering emails as part of my head of astronomy hat that I was wearing. And then the rest of the day, which has been much more exciting because I've been at work a long time today, I've been writing a proposal to use the Webb Space Telescope, which is the telescope behind me. That's not what it actually looks like at the moment. It currently is sat in a lab in California, but it will hopefully be launched next year. The way that we actually able to do some of the science that we want to do is that we apply for time on these telescopes on these different facilities. And then a panel of astronomers will try and look at all the proposals and try and choose the ones to be seen that will get observed. And so I've been spending a lot of my time over the last 2 weeks, and I'm sure many of my colleagues on the call have as well, actually writing proposals in anticipation for Webb. And I'm going to take you now in the order that I see you on Zoom. So I'm going to start with Jane. What have you been up to today?
Mostly adopting the you can wear pajamas because you're at home lifestyle. So I have been working frantically on trying to work on some spectra, which a colleague at another university has criticized. So, you know, got to defeat them by the end of the day. Also trying to help a student who's moved to the UK recently and is struggling a bit with her studies. And some meetings. So obviously a bit more static at home than usual. If I was in the office, I'd be going for regular coffee breaks with my colleagues at Cardiff and hearing about what they're doing and just, you know, kind of kicking the ball around, talking about new ideas.
Thanks, Jane. Naomi?
My day has been mostly just at my computer. I mean, we're all working from home now. So yeah, same as Jane, in my pajamas, like working at a terminal and just doing some programming, like coding and stuff. And then this afternoon I had a talk that I did for the UK Planetary Forum. And then here I am. That's the day.
Thanks, Naomi. Clara?
I'm in the US, so I still have a lot of my day left in front of me. What I'm going to do today is finish some slides for a talk I'm giving next week at Wired Live. But most days I just wake up, stay in bed for like an hour reading the news nowadays. And then I do all my clever things, all my quantum stuff, all my programming, hopefully before lunch. And then I have lots of meetings, more so now because of work that Jane led. I've got many more meetings and interviews than I'm comfortable with, let's say. But usually I try to finish work around 4:30 p.m. I think astronomers have a reputation of working really hard, and I do work very hard, and many days I break that rule. But I find that I'm most happy and most clever when I routinely finish work at 4:30. So that's what I would like to push for the future.
I've been working from home today. I'm not working from home full time. I go onto campus 2 days a week at the moment because like Steve, I also have face-to-face teaching. But today it's been mostly meetings and James Webb Space Telescope proposals. I've been discussing possible proposals to observe gamma ray bursts, so the giant explosions that end the life of massive stars in the very distant universe. This is something we've not been able to do until now, and James Webb may be capable of doing it. I've also spent some time talking to colleagues. We have an Astro Coffee via Zoom because nobody can give up their coffee conversations that Jane also mentioned. And I spent some time talking one-on-one with students today as well.
Thanks, Elizabeth. And finally, Jo.
So my day started with trying to persuade a 3-year-old that yes, it really was time to get dressed, which is always entertaining. a lot of it has been centered around James Webb proposals like others. So I've been trying to run some models to contribute to somebody else's proposal. That has involved rather more cursing at a server than I would like, but hey, here we are. Actually, something that was a real highlight, which is perhaps a bit different to what other people have said, is I got a resubmission of a paper that I reviewed back where the comments I'd made on the first draft had been really gratefully received and have made the manuscript a bit better. So that's a really good feeling when you get that kind of exchange with the author of another paper. So this is how peer review works in science. People write up their work, they submit a paper to a journal, and then the journal will find some other people that have similar expertise, send the paper out, and those people then have the job of looking over it with a critical, hopefully a constructively critical eye, and sending the authors back a bunch of comments to say, have you tried this? Maybe you should consider this. I quite enjoy doing that process, actually, and it's really nice to have some authors say thank you and mean it, because I'm not mean. I just try and make the paper better.
Thanks, Joe. I was just going to add, in sympathy with what you said right at the very beginning, I was woken up this morning at 5 o'clock by my daughter having a nightmare about a banana that she was eating, or that she'd eaten the previous day. She was saying, I don't like that banana, I don't like that banana. So I do appreciate that. This next question I'm going to direct to Jane. So this question is, do you need to study normal biology to be an astrobiologist? Because I hope you consider yourself an astrobiologist these days, Jane.
Yeah, that's a really nice question. I have to admit, I did not really do biology at school because my school back in the 1980s didn't have enough labs for everybody to do a lot of science. And you kind of had to choose, and biology was one I had to drop. And indeed later chemistry. So my background is mostly maths and physics. So what I've really benefited from, particularly recently, is having colleagues that do all kinds of other different things. So, if you want to know what an extremophile is, or an acidophile, or how, some tiny creature can live in acid, there's people I can ask. And our Venus project has been a wonderful collaboration of, like, eventually we decided we just had to ask each other, what do you even mean by that word? And that really, really helped say, like, I have no idea what you've drawn in this diagram. It's just a splodge to me. And that really helped the sort of clarity of thought as well as explanation, I think. So, yeah, I'm an astrobiologist that's really like a physicist, to be honest.
Thanks, Jane. And I know, Clara, maybe you can have a go at answering this question as well, because I know this reflects some of your background.
Yes, I published quite a lot in astrobiology because all my work is looking for molecules associated with life. But I didn't even do biology in high school. So I often find, like Jane has, that I really need biochemists around who can tell me, does this make sense? And I want to point out to anyone interested in astrobiology that perhaps even more so than any other astrophysics field, it takes a whole village. You need people who know chemistry and biology and biochemistry, but you also need people who know geochemistry to know if the molecules you see could be produced by something other than life. And you need people who understand observations and instruments and can program, and you need engineers. And one day we'll need poets to interpret astrobiological findings. And so astrobiology, I think, in particular, welcomes people of all fields. So if you're interested in it, I wouldn't worry too much about exactly which science you have to do. There are many avenues in, a lot of which don't involve knowing a lot of biology.
Just in case the questioner does have a background in biology, of course, that works too. I'm reminded of one of my distinguished colleagues who describes himself as a geomicrobiologist. And somebody said to him, is a geomicrobiologist a very small biologist that lives under a rock? And apparently that's not the case, but certainly you could get in from a biology angle and do actual biological experiments on the Earth that would inform things like extreme conditions like we might find on other planets.
Thanks, Jane. And I was just going to say that, so there's still hope for me to become an astrobiologist, given that I haven't done biology since I was, I think, 14 or 15. Great. So our next question is from Sophia, who wants to be one of the people who goes to Mars. And she asks, when do you think we'll send humans to Mars? Does anybody want to volunteer to answer this question?
I could say something, Steve.
Thanks, Elizabeth.
I don't have a definitive answer. I would say that a lot of the political initiatives we hear are currently not accompanied by enough political will and funding. So many of the timescales that are discussed, this idea of 2025, 2030, that's probably unrealistic just because the amount of investment that's required and the amount of technological development that's required is very high. On the other hand, NASA has invested a huge amount over the last 20 years in developing ideas for exploring human space travel. And that includes oxygen generation, it includes the production of food in artificial environments. They've simulated Martian soils here on Earth. So the technology probably exists, but the willpower and the funding are less guaranteed, particularly when we're prey to a short-term funding cycle. This is really something that needs sustained investment over a long period. So I think technologically it could be done within the next 10 to 15 years, but whether it will be done is a much harder question to answer.
Thanks, Elizabeth. Does anybody else have anything to add to that one? Okay, so the next one, again, I'm going to ask this to everybody on the panel. What is your favorite telescope? And I'm going to go with Joe first.
Oh, I think it's Hubble, because I feel like I've grown up with Hubble. My dad is also an astronomer, and he has used Hubble pretty much since it launched. And it feels like that's kind of us, even though we work in quite different fields of astronomy, the fact that we both use the same telescope has always been quite a nice link.
Oh, that's a hard one. I've worked with data from a really wide range of telescopes, ranging from gamma ray telescopes through optical all the way up to radio, but I'm going to be controversial here because I think that many of the others will name a telescope in particular. I'm going to say the telescope I simulate in my computer that can take the ideal observations and help inform me and my colleagues about the best way to use the limited telescope time that's available. So yeah, that's what I'm going to say.
If we're allowed future telescopes, then I'm going to say Ariel, since it's now approved and will definitely happen. And it will be kind of the first large telescope to focus on exoplanet atmospheres. So that's what I'm most excited about. But I would like to do an honorable mention for Arecibo, which has just sadly been decommissioned. And it was a really important telescope in my path to becoming an astrophysicist, because of the movie Contact, where it was featured heavily. So really heartbroken for Arecibo, and RIP.
Thanks, Clara. And yes, yeah, this news today about its potential loss, it's been one of those iconic telescopes for the last, 50 years almost. Yeah. Naomi?
I have probably my favorite telescope is Spitzer, because that's the one that I work with the most. But we have a love-hate relationship because obviously with the Spitzer data, we can't even look at the planets really. It's literally a point source, so we treat it like you would treat a distant star. You just look at the light that comes from it, and you split that one piece of light up. So that's kind of sad that we don't get these pretty images that you get from ground-based telescopes, like the BLT, which is really awesome, and the Keck telescope as well. I love the ground-based telescopes because they have these beautiful images of the ice giants.
I have to say my current favourite is the eMerlin radio telescope network, which is in the UK, which has the advantage over some of the space ones. You can go and see it at work. So if you go to the Jodrell Bank Visitor Centre in Cheshire, you can see some of the telescopes. Some of them are also just scattered around the UK countryside, so you could see them from the road, take a selfie with them or whatever. And they do incredibly detailed images, pictures of radio wave emitting objects. So we're using that to look at some of the swirling disks of material around young stars in our own galaxy to see where planets come from. So I think that's got got everything going for it.
Thanks, Jane. And just to add my own favourite telescope, I think I have to agree with Joe here, the Hubble Space Telescope, because I grew up with it. It has been a kind of a fixture of both my career and one of the reasons why I went into astronomy. And for those who don't know, this is the 30th anniversary of the Hubble Space Telescope this year, so it's past its 30th birthday now. So thanks. So I just lost my next question. Okay, so my next question is about Mars, and I'm hoping that one of us can answer this. So what would we need to do to establish a permanent settlement on Mars? Do you think it's possible in the future? Are there the raw materials available on Mars for us to thrive there? Elizabeth is unmuted, so I'm going to choose her.
I have unmuted partly to say that I will touch on this in my talk for National Astronomy Week tomorrow evening in a bit more detail, so there will be more time available then. But broadly speaking, yes, there are resources available on Mars which could be utilised. It would be a very expensive and difficult operation, and it would carry substantial risks for any settlers. It's not a friendly environment, but it could be done theoretically.
I did once see a fascinating talk by a group in the west coast of the US, I now forget, where they were pushing for a construction materials solution on Mars, because obviously you don't want to take all the bricks and the cement with you in the spacecraft. And their incredible solution for this, although Elizabeth can probably say if this is insane, was to basically have inflatable structures that are filled with spores, so mushrooms. And then when you get to Mars, the waste products of just people being on Mars will be the food for the mushrooms that grow and create their own construction material to fill the walls of this inflatable habitat. And I don't want to be told that this is impossible because it's too cool.
Thanks for that. And I think a related question, which I'll just mention, but maybe we won't answer, is asking how accurate the film The Martian is. And is that how we would imagine Mars to look like, perhaps one of these missions? I think The Martian is, in the terms of science fiction films, is one of those that's kind of up there at a kind of good level. I'm glad that Elizabeth is nodding her head there. And I think, obviously, Elizabeth was probably going to talk about this tomorrow in her talk, so I might defer her question to that. A related talk, though, which I thought I would ask, is what sci-fi movie is scientifically the most accurate? I'm going to turn this one on its head, and I'm going to ask you which is the most accurate and the least accurate, right? And we're going to see who gets the best answer. So I'm going to start off with this, again, chair's privilege. And the least accurate one, I think, is the film Sunshine by Danny Boyle. The premise was the sun has stopped nuclear fusion in its core, and we have to send some astronauts to go and restart the sun with a very large nuclear explosion. There are so many things wrong with the science in that film that I really don't know where to start. On the other end of the scale, I'm not going to say a film, I'm going to say a TV series, which is The Expanse. So although it does include very strong fictional elements, a lot of it is based on kind of technology that we could do. So the way the spacecraft move and things like that is quite accurate for what is essentially a space opera. And so I'm just going to give everybody else the opportunity to answer this question and give me your most accurate and least accurate. So I'm going to go with Naomi first because she's laughing.
I love this question. So I would say the most accurate one that I know of is Interstellar. I've got the book upstairs, which is The Science of Interstellar, and like the maths and stuff behind that, and how time slows down when you get closer towards the black hole. So cool, so cool. And then the least accurate, I think, that I've seen is a Chinese movie called The Wandering Earth. I don't know if you've seen that, but they use, well, it might be a spoiler if I say what they do, but they use the gas of Jupiter and they set it on fire. So good, so good.
Thanks, Naomi. Clara, because you're the next person laughing.
I have not seen that movie, but I'm so keen now. This sounds incredible. So I would like to put a wrench in the works and put Interstellar on the bad list because the fifth dimension is not love. So that's going to be my take on that. And for accuracy, I would like to have a shout out for Arrival, which really showcases quite how hard it would be to communicate, even with an advanced civilization. So yes, sorry, I know I'm being controversial.
So now I'm laughing so hard I can't think. I'm going to use two very old examples. So a good one, 2001: A Space Odyssey, I think was made before the lunar landings, and they seem to get so much right with what a space station could look like, zero gravity, you know, the technology. I think that was incredible. And then also try to think of a really bad one. I have this strong memory, and I think it may have been an episode of the 1970s TV series Blake 7, which had a very low budget. It's a very cult thing. And I think they did the approach to a black hole by swirling a cup of black coffee for the graphic.
So for my favorite, it's only a little bit of the film, but it's great. My daughter loves Wall-E, which is the Disney cartoon about the robot. And there's a wonderful bit where he dances with the other robot, Eva, and the way that he dances through space is to use a fire extinguisher to provide the thrust. And it's just brilliant. It's such a lovely sequence, and it's done really well in terms of the forces that he's trying to control. In terms of the most terrible one, it's probably The Day After Tomorrow, which I had the great good fortune to watch with a bunch of geologists at Cambridge, with pizza and wine, and we just ripped it to shreds because it's just terrible. They run away from cold around the corner of a corridor, and the cold just follows them around the corridor. It's just impossible. So that's my favourite terrible one.
Thanks, Joe. Elizabeth?
Ooh, a lot of the good and bad ones have already been mentioned. For spectacularly bad, I might mention Santa Claus Conquers the Martians as being really quite silly. On the good side, I think I'm going to go off-piste and mention a radio program, Journey into Space from the 1950s. It stands up remarkably well in many aspects in terms of its portrayal of rockets, gravitational dynamics, and how people might approach exploring the solar system. So Charles Chilton's Journey into Space, that was on BBC Radio.
Thanks, Elizabeth. I'd just like to give honourable mention in the bad category to The Core, which is where it's very similar to Sunshine, actually, where a group of scientists and engineers have to drill into the centre of the Earth and restart the Earth's dynamo, which was particularly bad. But on consideration of everybody's answers, I've decided that, in fact, I was correct with the worst one, and Sunshine is the worst. Thank you all. Just to note that we're really getting to the end now. So we've got another event starting at 7 o'clock. So I think I'm only going to have time to ask one more question. And I'm really sorry, because we do have a huge number of questions that are left here. The next question is, I'm going to give people the opportunity to say one last thought as before we leave, but also one of the audience has asked if we can link to any talks, or do we know of any talks that are happening in the near future. So again, I'm going to go in order of my screen. I'm going to go with Jane first. So do you have any final words, and do you have anything that you want to point people to in particular?
I think for talks, I can't think of anything particular, but look for astronomy clubs online, will be fantastic talks. And yeah, just to say thanks. It's been an unusually brilliant set of questions. Thank you.
Thanks, Jane. Naomi?
I don't know of any talks that are soon. Next week there's one that's Earth to Earth. I can put a link somewhere, but if you search Earth to Earth, I'm doing one with a colleague about atmospheres of the Earth and also Uranus and Neptune, and that's next Thursday.
Thanks, Naomi. Clara?
I don't have any talks off the top of my head. And I also realize that a lot of people, sorry, I've got a lot of sun here. A lot of people are very busy. And so I was going to suggest a podcast. And if you haven't become bored of my voice yet, I did a nice one with Alan Alda and his podcast. And he's just a very charming old man that I recommend listening to.
MASH is one of my favorite TV programs of all time, so I'm so jealous.
For the MASH fans, yeah.
Elizabeth?
So as I mentioned, I'm doing one for National Astronomy Week tomorrow, and indeed I know there are also National Astronomy Week meetings on Sunday. Beyond that, I think Exeter Student Astronomy Society are trying to organise an entire conference of public talks for next March. I'm not sure if they've set a date yet, but it's something to look out for, because they've asked if I would be interested as well. Well, that's not the only reason, but there are many reasons to look out for that.
Thanks, Elizabeth. And finally, Joe.
So there aren't any talks coming up, but there is if you're into exoplanets, there's a great podcast which I've been a guest on once called Exocast, and they're currently running a World Cup of exoplanets via Twitter. So exoplanet scientists, this is pretty much the highlight of our year. We get to watch our favorite planets battle it out with each other. So I really recommend looking them up.
Thanks, Joe. And I'm going to just shamelessly self-promote a talk series that I've been involved in. This is a talk series called Sussex Universe, which you can find online. This is a lot of pre-recorded talks, but our next talk is next Tuesday, given by one of my PhD students actually, on a completely different topic, but you can find out all about that online. And at this point, I'm really sorry that we didn't manage to make all the questions. We have been inundated with lots of fantastic questions. I just want to thank Lucinda and the National Astronomy Week organisers for facilitating all of this, and obviously all of the great panel members for all of their contributions tonight, and all of the audience for joining. It's now 7 o'clock, and it was great to see you all. Thank you. Hope everybody has a good night, and do enjoy the next event if you do it.
Yes, thank you all, ladies, for being with us. You are welcome to hang out. If there are any questions in the Q&A that you can still answer, you are welcome to type them in. Stephen, thank you so much for being such a great host for us today, and having this panel for us. It's just been amazing. I have with us our Astro hosts for tonight. We have David Arditi, who is going to run us through all the practical astronomers. David, how is the weather out there for today?
The weather is terrible.
I was afraid you were going to say that.
The good news is the fireworks have stopped.
That was November 5th. What is the date today? I think we're around the 20th of November already. Just 2 more days left of NAW. It's been such a wonderful time we've been having. And again, another night of some possible observations. It doesn't sound too good.
No, we're clouded out here in London, and I hear Eric Walker, another of our panelists, he is clouded out in the Highlands of Scotland, and even Agapios Elias in Cyprus, he's reporting cloud, and Ian Sharp on the south coast is unfortunately reporting cloud as well. However, we have had a very clear week, or some clear nights this week, and I've got many observations from the last week or so that I can show you, and I'm sure we can answer some of the questions as well, and show you some other interesting things that you can be looking for in the sky in the next few weeks and months.
Fantastic. Well, I'm going to leave it with you then. Thank you so much for you and your crew being here. We'll see you in a bit.
Thank you very much, Lucinda. Before I go any further, I'll actually deal with the question about telescopes for a 10-year-old child. An interesting question. And it so happens that I have written an article on this subject, which I will show you. The article on the subject. Yes, so I'm a member of the British Astronomical Association. Here's the website of the British Astronomical Association, britastro.org. It's the largest and oldest association group for amateur astronomers in the UK, and one of the most important in the world. And we've got many sections, and so here's our website, and on the right hand side there's these various sections. Now, of particular interest to National Astronomy Week might be the Mars section, but I'm going to mention that I'm the director of the Equipment and Techniques section, which is all about telescopes and observatories and so forth. And we have some pages about buying and using telescopes. And I've actually written an article, What Telescope Should I Give a Child? And gone through some of the possibilities and shown some telescopes that might be appropriate for a child in the cost range of around 150 pounds. And I wrote that a couple of years ago, so it might, some of the models might have changed, but the general guidelines of the types of telescope that you might find reasonably inexpensive and still work quite well are there. And there's also an article on the National Astronomy Week website about what telescope to choose. So you can get a second opinion from there, although I think the opinion will be quite similar. I'll show you what it was like here last night. So I'm in my observatory currently. I'm in the shed just next to the telescope shed, and I can look out of the window and it is solid clouds. So I'm not opening up the telescope to light tonight because it might get rained on, but it actually was clear last night. And this is what Mars looked like through my 14-inch telescope last night. Hopefully you can see that, and I can run this video. And here's the video.
It looks good, David.
That's the video, yes. So that's Mars last night, and that's an astronomical view. So it's south at the top. You can see the south polar cap just very faintly up there. This is terrible seeing. This is a lot of turbulence in the atmosphere because we've had a lot of cold fronts and warm fronts and so forth coming over. Rapid Atlantic jet stream weather has been making the image very turbulent. And well, we can see a little bit. We can see some of the albedo features in the southern hemisphere, and we can see this lighter area just towards the top of the image here, just to the left of the south polar cap. And that's actually the dust storm that was reported about a week ago or 2 weeks ago, observed by astronomers on the other side of the world, Australia and Far East kind of longitudes. It started in Valles Marineris, and that part of Mars has now rotated round. So we're starting to see that part of Mars from the UK, and the dust has spread out. It's no longer just in the valley. And we await to see what it does next. It might fizzle out, or it might even go on to cover the whole of the planet and obscure the albedo features on the whole of the planet. But I think at this season of the Martian year, when it's going into the autumn in the southern hemisphere of Mars, I think that's probably unlikely. There's probably not enough energy in the atmosphere to create a global dust storm, so it's quite likely to fizzle out. What else can we see in this image? We can see this little sort of bluish patch at the northern area. That's the northern polar cloud hood. But really we can't distinguish very much in this image. I may show you the processed version of this later, but that's a thing that some of our other panelists will talk about as well, how we go from a raw video like that, that's the completely raw footage from the telescope, how we go from that and produce the final high resolution results. And I think we'll say a bit more about that later. But at the moment, I will introduce Eric. Eric is in the Highlands, and he's going to tell us what astronomers get up to in those parts. So I'll hand over to Eric now.
Good evening, David. How are you?
Yes, I'm very well, thank you. Very busy with all these Zoom talks and being asked to be on panels and things like that. Yes, and we have had some clear sky in the last week, but there had to be one day where it was cloudy for everybody.
Oh yeah, absolute certainty.
So we took that account of that in the planning.
Okay, right. I'm going to just share my screen, David. And hopefully people can see that.
We can.
Excellent. Right, well, good evening. My name is Eric Walker and I'm the chair of Highlands Astronomical Society. And I was intending tonight to bring you some deep sky, live deep sky observing via webcast, and we were going to look at some of the old favourites. However, life being what it is, the weather is not being kind to us. I have thick cloud, I even have a bit of rain, so it's over to plan B. I'll give you a little talk about what our club is, what it does normally, how the coronavirus pandemic has affected us, and how we have worked out solutions to actually cope with it and, in fact, improve our club. So this slide here shows you where we are, and we are pretty far north. We are 57.5 degrees north, far enough north that we're able to see the northern lights. And I've got a couple of pictures of those that we've taken, so I'll entertain you with that. This zoomed in map actually shows you my observatory. I'm slightly north of Inverness near Dingwall. Our observatory, our club one, is based right next to Culloden battlefield. So if you're ever up in this area when things get back to normal, aim for the National Trust Centre, Culloden battlefield, and you'll find us right at the corner of the car park. This is how you can get in touch with us via the web. Facebook, we're very active on Facebook, and that lets you know what we're up to live. Instagram, we post all our astro photographs on there. And do subscribe to our YouTube channel. That way you'll be able to see our meetings, our monthly meetings, and our live webcasts, and you'll get notification of them. Our club, like many other clubs, we hold monthly club meetings. We have a very intensive practical observing program, which includes pop-up observatories throughout the year, and I'll explain a bit more about that later. We have a very active astrophotography group, and we do a lot of STEM and public outreach. Do a lot of STEM to the local schools, colleges, things like that. So very, very active club up here in the Highlands. Here's a few photographs. This is one of our observatory at Culloden. We have a big observing dome with a 14-inch Mead Smith Cassegrain in there, and a very welcome warm room, which keeps us warm on the extremely cold nights we get up here, especially January, February and mid-March. You'll notice that we have a rather high wall. That's because we're on Culloden Moor and it is windy, to say the least. When it's not windy, we can set up our scopes outside the wall, and we have a huge viewing area with a very, very good dark sky south vista. Here is a scope set up, and here is some of our pop-up observing that we do. This is in the summer. We have solar scopes, and we take our solar scopes to various areas where there are tourists quite often, and you'll see some people looking at the sun through the scope. And this was Belladrum Tartan Heart Festival, where we set up our scope for 3 days, and we had over 1,000 people came to visit our observatory and our display there. That was a fantastic event, and we would love to be able to do that again. Now, the back end of last observing season, so for us that's end of February and March, we decided that we would set up a facility so we could enable people with limited mobility or perhaps had difficulty looking through an eyepiece. So we set up a high-spec astro video camera onto our big 14-inch scope, and we hardwired it through to the warm room so people could observe on a flat screen, and we had an observer there who was talking them through. And this is the type of picture we were getting. Very good picture. You see all the structure of the Orion Nebula M42, M43, and you can see the colours and everything. And we were really pleased with this. So this, as I say, was coming up to the end of March. We start to lose our night time because we're so far north, just at the back end of March. So we were all looking forward to this observance season coming up. What could possibly go wrong? Well, we all know what went wrong. Coronavirus pandemic, massive restrictions on meeting up with people and mobility and everything. So what on earth did we do? We had to cancel our forthcoming April meeting, and to be honest with you, it took us a month, perhaps more, to actually get our heads around what had happened and what could and was happening to our club. So we did like many other clubs, not just astronomy clubs. We started to hold our monthly club meetings online via Zoom. Something great came out of this, in that all the local astronomy clubs in the north of Scotland, Aberdeen, Elgin and Moray, our one, Caithness, North of Orotzy and the Orkneys, Shetland, Stornoway and Isles of Lewis and Harris, Cairngorm, just north of Aviemore. We all got together and collaborated, and we have loosely formed a North of Scotland Amateur Astronomy Association, which we colloquially call NOSA, not NASA. In the summer, I was part of a science festival, Orkney International Science Festival, and I was part of both the technical and the presentation teams, and I learned a tremendous amount out of that. And we were able to form a small group in our club, and we designed and constructed live observing webcasts at high resolution, because we found that people weren't just using their computers to look at things, they were starting to use their smart TVs. So we geared up to ensure we could meet those requirements. And we're interactive with the co-hosts and with the audience, so they can all participate. And it's been extremely successful. We can't do it from our observatory at Culloden, so we have to do it from my backyard observatory. So it's a smaller dome than the club one. This is sitting in the back garden. And inside, I have a Celestron 11-inch Schmidt-Cassegrain telescope on a good, robust CGX equatorial mount. Although the laptop isn't here, it's all hooked up to the laptop and it's all driven and controlled by that. The secret, of course, was this ZWO high-resolution astro camera, and I've got a focal reducer on there to widen the field and speed the camera up a bit so I don't have to expose for too long. And we have a whole heap of 3D printed accessories. This is great for us because it saves a lot of cost for high-spec equipment that we can now design and make for ourselves. The equipment manufacturers are probably not so happy about it. But this is the setup that we have, all hooked up to the internet, of course. And the best way to show you what we do is I've got a couple of clips of like about 30 seconds a minute of some of our webcasts, and I'll just show you what we do. So here we go, Albireo, the double star. So what I've got is I've got my telescope hooked up to the sky map, and it actually moves the scope for me now. I've in good old blue Peter parlance. Here's one I made already, and I've actually got the scope sitting on it. So I'm going to fade into the camera, and hopefully you can see the star Albireo. And something that you might notice about it is that Albireo is not a single star at all. There are actually two stars.
Yeah, you can see it nice and clear.
Yep. So there you go. Double star, not a challenge. How good is it though? How good is it on something like a planetary nebula at magnitude 8.8 or whatever? Oh, here we go.
Wow, there you go. That's really fantastic, Eric. And this is one that always shows up colours very easily.
Yeah, so I'm just typing in to Pete. He's wanting to look for the ET cluster, but I don't think my field of view is going to be wide enough. Oh, I think Dave Ord likes this. I think a few people like it. I'll try and zoom in on it, actually. Okay. Oh, yeah. Actually, not bad at all, guys.
Got a wow from Dave.
I've got a wow from a few people there, I think. Yeah.
Okay, so that shows you how good we are at getting that type of object. We thought we would really try it on what we call the Outer Limits galaxy. This is a fantastic object, and it's very, very faint. I've just got to tell you that we were looking through this through faint, hazy skies, so this was quite a catch. This was a wonderful thing to find.
That is really staggering to be able to see that.
Oh, just really chuffed that Dave, James is on, and that he reminded me of that one, because you can't have an observing session with James without trying to see that one. Now, I wonder if I can zoom in. Oh, look at this. Look at this, guys. Now, you can quite clearly see the dustling. This is an edge on spiral, isn't it?
Astronomy Society is quite right. Outer Limits is more
outer limits,
more likely than the Twilight Zone.
Yeah.
So that just shows you what we've been able to achieve. The virus, the coronavirus restrictions have forced us down the road of something we were probably wanting to do. And it might have taken us 5 or 10 years to get there. So it's forced us to do something we do, and I think we're doing it very well. We're getting good attendance, good audience figures for this, and great feedback. So I'm just going to finish off. We've got a very active astrophotography group, and I just want to show you some of the pictures that we get. We're quite proud of them, so I'll just click through them very quickly and let you see. These are ones taken very recently of the moon, one of my favourite phases of the moon, and you can see the structures, but also you can see some of the colours due to the geology of the rocks. Some close-ups there. I'm not going to go into the details of it. I just sit back and enjoy the pictures. They're quite arty as well. There's some wonderful detail and structure in there. The solar scopes with the sunspot areas and the prominences. It's a Mars week, of course, so we couldn't not show Mars. There's a wonderful one of little Mars up there, and the moon, wonderful conjunction. And the day after, Dave, who was my co-host in the videos, he got this beautiful picture of a 22-degree moonlit halo with Mars sitting inside it. Lovely capture. There's Mars. Dave stuck a camera on the end of his telescope, and that was one of my attempts. Nothing like Agapios, who I've seen the fantastic pictures that Agapios gets. That's one of my stacked pictures. It's probably the best one I've ever had. I'm still hoping to get a couple of nights where I can get better than that. As I said earlier, we are in 57.5 degrees latitude. We get the northern lights up here. They're not always as good as this, but they're very often pretty good. So there's just a couple of wonderful pictures for you. If you're ever up here at the equinoxes, bring your camera. Wonderful, wonderful sight, the northern lights. And then this is more our speciality stuff, where we're looking at the Heart Nebula with specialist filters and extremely long exposures and quite tricky processing techniques to get it. But we can get this because of the clear, dark, stable skies we have up here, especially in February and March, when it's very, very cold and the sky's dry, the air's dry, and the atmosphere is stable. So just a few more pictures. That's us. If you want to get in touch with us, those are our contact details. David, thank you very much. It's all work this time. No fireworks.
That's fantastic, Eric. I'm even getting your name right this time. So
good on you.
That's progress, isn't it?
Yes.
Yeah, I think you've done very well there with setting up that video system, and it's a different way to take observations. And this fantastic electronics we have now allows us to see things that we can't see with a given telescope just by eye, but we can see them with the camera. And it allows us to see more detail as well on these faint objects. But I would say that there's, you might agree, you say if you disagree with this or not, but I think there's still nothing like the photons entering your own eye and seeing those light particles directly impinging on your eye and on your consciousness from those billions of miles away. Millions of light years away from those distant galaxies. That is such a mind-boggling thing. And so when this epidemic has abated and it's possible for local astronomical societies to hold events where the public can go and look through telescopes and see some of these amazing things, I'd encourage you all to seek out your local astronomical society and to go there, and wherever you live, whether you live in a dark place like the Highlands or even in a bright place like London, you can still see a certain amount, and seeing it with your own eyes is just a different thing entirely. It's like the difference between being at a concert and listening to a recording. It's just a different experience.
Yeah, I think there's a place for both techniques, David, you know, and the trick is going to be getting the balance right, whatever that means, once we are able to get back together again. Because once you've used the technology, it's hard to unuse it. You know, you can't uninvent something. So I think there's a balance somewhere that we're all going to have to find.
That's true, and I think the current episode has changed permanently how people do things in our hobby, and as in many other areas of life. I suspect there'll be a big demand for online meetings in future, where we can get people together from different parts of the country and different parts of the world, like we're doing tonight, easily. We'll probably carry on doing that.
Yeah.
Well, we've had a question, which I think is quite a good question, from a young lady, age 10, whose name has now escaped me, but she said, what's the best object to look at in the sky for a beginner? What's the best object for a beginner? Well, I'd say the moon, because it's easy to find and it's bright. And if you look at it with binoculars, you'll see a lot more detail, and you may even be able to make out some of the craters, and you can follow the changing appearance through the different phases of the moon, and you can even see it through clouds to a certain extent if you've got thin clouds, and you can see how the shadows change and how the appearance changes with the changing illumination. So I'd say the moon. What would you say, Eric? What's the...
Yeah, I would agree with the moon as an object, but I would step back a bit and say, look at the sky as a whole and look at the patterns of the stars in the sky. Look at the constellations and what we call asterisms, little patterns within it. Learn those, and that will help you work out where other things are in the sky. You know, learn your own sky map. But as an object, I would agree with you absolutely, David. I think I was brought up with the moon because I was brought up in the 60s during the space race and the Apollo mission. So the moon was a big thing, but it went out of fashion, you know, in recent times. But yeah, great thing. So that's my answer anyway, David. Yeah.
Yeah, I'd agree. It is very useful to learn the constellations. We've got all this technology these days that will identify things for you. But if you, I mean, I'll tell you what I did, because I got interested in astronomy at the age of 11 from reading a book by the late great Patrick Moore, and his advice was to go out in your back garden and learn one constellation every night. You start with the easiest one, which is the Great Bear, and then you work out from there and that's what I tried to do. I tried to learn a constellation every night. Some of them were just too faint to see from my light polluted sight. So some of them I've never really learned, but the ones that I learned then, which were all the main ones, like the Great Bear and Orion and Taurus and so on, it's now second nature that I know where those are and what just seeing a few stars in a cloudy sky, I know what the rest of the sky is like, because I have that picture of the sky in my mind. Like,
and the other thing, of course, David, is that you can then use little triangles and squares and lines of stars as pointers to go and try and find slightly harder to see objects.
That's right. Yeah, we've always worked from the brighter objects to the fainter objects. And then when you get a telescope, you're very well equipped to find your way around the sky with a telescope, which is difficult, obviously, because a telescope only shows a small part of the sky at once. And you can start to find some of the interesting telescopic objects by moving from star to star hopping, as we call it. And it's so much fun doing that. It's a journey of discovery.
Yeah. I was just actually wondering, you know, that's a wonderful article you've written on the BAA website, by the way, for the telescopes, you know, for a child. I'm just wondering if that 10-year-old young lady is the same one that asked the question in the previous part of the night session. I was wondering if she's considered binoculars, because binoculars are a wonderful tool to have. Again, you point them at the sky and what you see is what you get. They're quite intuitive. Anyway, that's just, again, that's another take on things. There's a lot of different solutions to a problem, isn't there?
Indeed, nearly everybody has binoculars stuffed away in the back of a drawer somewhere. So yeah, get them out and start looking at the stars. And the planets as well. We've got a very nice grouping of Jupiter and Saturn in the early evening sky. So if you can't stay up late, you can definitely see that just at sunset, just about between 4 and 5 p.m. at the moment. Look to the west, those two objects. The bright one is Jupiter, very low down, and slightly higher, slightly to the left of it, you've got Saturn. And look at those with binoculars as well. And with Jupiter, with good binoculars, you'll be able to see the 4 main satellites. You'll be able to see the Galilean moons, the moons of Jupiter discovered by Galileo, as 4 little bright points. And if you follow them from night to night, you'll see them moving around in their orbit around Jupiter.
Sure.
So let's move on. Let's move on now to the opposite end of the country, to the south coast, where Ian Sharp is on hand, as usual, to give us some good practical hints and tips.
Yes.
What have you got for us today, Ian?
Hi, David. Hi, everybody. I hope you can hear me okay.
Yes, can hear you. Yes.
Well, I'm cowering in my office again. This is my 3rd session, which has been completely clouded out, and it is raining, or has been raining, I should say, rather. So what I'd like to do this evening is to give you some ideas on how it is we take and process some of these marvelous deep sky images. We've heard a lot this week, of course. The Mars week has dominated about how we process images of the planets and how we take images of the planets. But I'd quite like to show you the other end of the spectrum, if you like. How is it we take pictures of these wide field, much fainter objects, and give you an idea of what to expect if you try to do this. I'll just quickly, I've done this before. Forgive me if you've seen these before, but I'm on the south coast near Selsey. I have lovely skies here, dark sky sight near the sea, overlooking the Isle of Wight. Here's the moon and Venus over my observatory. And I'm an all-rounder. I take pictures of comets. I take pictures of the planets like Jupiter here. I travel. This is taken from Barbados, so I haul my telescope all around the world. I rent time on telescopes. This is the Trifid Nebula I took with a telescope that is in Australia, and this is taken from my back garden, M78 in Orion, and again a picture of a galaxy. So these are deep sky objects, these last few images that you've just seen. This is Mars, by the way, just to finish off the picture, and here's Saturn. But what I want to do now is I'm going to share a different screen here. I'm hoping you can see my screen now. Can you see this? This is a picture of inside of my dome. And the reason why I want to show it is it's when you take a picture of a galaxy or a nebula, it's very faint. And what you need to do, which is completely different than the planets, is rather than taking thousands of very short exposures like we do with the planets and try and pick out the sharp ones, you need to expose the object to your camera or your CCD camera for as long as possible, ideally. And to do that successfully, you have to make sure that your telescope tracks the objects perfectly. If you don't do this, you'll get movement, and your stars will be blurry and round. They won't be round, and the object will be blurry. And there is a couple of ways of doing this. This telescope, this is my telescope here, and this is an equatorial mount where it's aligned to the pole of the planet. So there's a motor that turns this round once a day, and that keeps the telescope guiding the stars. But to be more accurate, what you need to do is that this little telescope that's riding piggyback here is actually a guide scope. So there's a little camera here. It's actually a planetary camera that I actually use this very camera for Mars. But in this case, I've redeployed the camera to guide on a guide star. So the main telescope will be pointing at the galaxy, say, that I'm trying to image. And this little telescope will be pointing at a star, a fairly bright star, doesn't matter too much, and it will be sending little corrections to the computer control mount, and it will be keeping the object in the center. So that's the first thing to realize you need to guide. And I'm just going to show you this last picture is just because the pictures I'm going to show you that were taken with this setup. Here's a much smaller telescope. It's a 3-inch refracting telescope, which has got a lens here. And this is my CCD camera. This is this camera here, by the way, is a regular DSLR camera, a commercial camera. And this is a commercial DSLR called CCD camera, which is a more specialized camera, but there are many available now. They're very widely available. And this wheel here contains filters that are driven around, and I can take pictures through a red filter or a blue filter or a green filter with this setup. So this is the setup that I use to take some images that I'm going to show you now. And when you first perhaps take an image of a galaxy, this is a 5-minute exposure guided on 2 bright galaxies, Bode's galaxy, M81, and another galaxy near it called M82. Now, when you first get the image back, you might be disturbed to realize that it's almost all black. And that's how, after 5 minutes, using a very sensitive CCD, that's how the image actually comes off the camera. But if I do something, I click a button here, what I've just done is I've stretched the image. The information is all there, but it's all clustered at one end of what we call the histogram. I'll show you a little bit more. And what I've done is I've spread that image, that information out, so that it's now more linearly covering the output of the image. And so that now we're seeing the galaxy M81 and M82 here. If the moon was in this image, it would fit in this image quite comfortably. So Mars would just look like a star, for example, to give you an idea of the scale. Now, there are lots of challenges with deep sky imaging, and what we need to do is we need to get rid of the noise. This looks a little bit noisy, although it doesn't look too bad. And we also need to improve the image. If you look at the image, I'm going to brighten it up even more. You can see I've brightened it up too much here, but you can see that there are dark bits on the edges and the corners because the telescope does not illuminate the chip of the camera properly, and we need to deal with that. And you'll also notice little black dust spots here. due to like dust motes that are sitting in the system. And one of the skills is to get rid of these imperfections. So I'm going to show you the next image where what I've done is, again, it's black, and I'll brighten it up. Now this looks much flatter. You'll notice that the black, I hope you can see this, by the way, and I'm hoping that you could have seen what I was describing. I'm hoping it's not too fuzzy over the Zoom call. How did it look, David? Does it look okay?
It looks very sharp, yes.
Oh, okay, thank you. So what I'm saying is not, you know, it is visible. So now this is a single 5-minute exposure where we have compensated for those imperfections. And we do that by taking separate images through the telescope using a very flat field of view, like an evenly illuminated wall, or a flat screen with a white screen. And we can then subtract that from the image and get rid of those imperfections. Now, the next step is to take lots of these. Now, this is one 5-minute exposure, and it already gives quite a nice field of view, a view of the two galaxies. And what we really need to do is to take as many of those as we can. Obviously, this can take hours. And one of the beauties of deep sky imaging is the fact that I could take these were taken last year, about, I think it was in something like, I can't remember what month it was, to be honest, but that doesn't matter, because I can take those images, I can take some more this year, and I can actually use them and keep adding and adding those images, because the objects are so far away, they literally do not change at all over a year or several years, many years in fact. So you can build up a library of these images, and you can then start adding them together. And just like planetary images, where we average and average and average lots and lots of images to reduce the noise in those images, we do exactly the same thing with deep sky images. And we add them together. So I think I took about 10 images that night, 10 5-minute exposures, and this image now is basically all of the images added together, and you're starting to see more structure in and more faint objects. You can see now there's like a bit of a haze. And in fact, this is there is a lot of nebulosity around these galaxies, and you're starting to see other little small galaxies around as well. So this is now the result of stacking 10 5-minute exposures. And so that's, say, 50 minutes, nearly an hour of total exposure. And I would perhaps go on to add more and more of these together. And eventually you would end up with something. Now, what I haven't said here is, and I apologize, is that all these images were taken through what is called a luminance filter, which is basically a clear filter. And so there is no, not here showing you color information, but what we do is we go on to add images taken with the red filter, and then a green filter and a blue filter, and we combine those together to give us color images. This is just a luminance example. I just wanted to give you kind of an idea of the techniques just by using these. And I think this is this ends up as my final result, where when I've done a bit more processing, and I've probably actually cut the background off a little bit too much here. It's probably a little bit too dark, but you can still see the background nebulosity here, and you can also see more structure in the galaxy here. And if I zoom in a bit more, then I'm actually zooming in 2 to 1. So you can see the noise creeping back in, but you can see quite a lot of structure there in this lovely spiral galaxy that is Bode's galaxy. So that's it. The principles, the real key is guiding. There are a lot of telescope mounts now on the market. And my advice, if you are serious about astrophotography and doing deep sky work, in fact, doing any astrophotography, my advice is buy the mount first. Put your money, shall I say, into the mount. The better the mount you can afford, the better is going to be your experience, the more robust that mount. You can put different telescopes on that as you go. But if you have a rickety mount that is not capable of carrying the telescope, then you're going to be in trouble. So anyway, that was pretty much the flavor I wanted to give about how we process and how we take and process deep sky images in astronomy. So was that okay, David? Anything
Thank you very much, Ian. That's lovely to see all that. It's a big subject, isn't it?
Oh, huge, yes. It's how do you start?
It's a complicated subject. That there are a few books on it, but you can also ask the experts. You can join a society, as I said, and you'll find people who can help you, or through the British Astronomical Association website, you can reach us, and we can try and answer the questions. Or there are various forums on the internet. There's one called Cloudy Nights Forum. There's a Stargazers Lounge, is more of a British-based one that has lots of people with lots of expertise. We've got a question here that's kind of related from Keshav. It says, do I need a dew heater on my camera lens for astrophotography?
Were you asking me to, or?
I would say yes, but
no, okay, yes.
What would you say?
Yes. Well, it really depends on the night, but yes, I have some. I've got some over there in the back of my office. Perhaps I'll go and dash and get one. Yes, these are little bands, like Velcro bands that you can wind around the lens of your telescope or your camera lens, and they're normally powered by 12 volts, and you can buy little. I've made my own little dew heater controllers myself, circuitry that is quite easy to build, or you can buy commercial ones, and they just gently heat up the lens and stop the dew. But if it's a breezy night, a breezy evening, the chances are if it's not one of those dewy nights, where things are getting damp, with the dew, then you won't need it at all. And there are many nights where the lens will remain perfectly clear all night, but they are advisable if your camera lenses in particular do dew up quite quickly. So.
Yeah, I find this is a tremendous problem, and if you can't get a dew heater organized, what helps is just getting a piece of cardboard and making a little cylinder of it,
yes,
and sellotaping it to the camera lens, and that will probably delay the dewing for half an hour or something, maybe allow you to get your images in before the dew takes effect. But yes, in the British climate, dew on optics is a constant battle.
It is.
So somebody has asked, how come Mars has not got oxygen? Well, I know the answer to that one. It's because oxygen is very reactive. And so a lot of the oxygen on the Earth is trapped in the rocks. It reacts with other things to make rocks, like carbonate rocks and so forth. So we believe that oxygen is actually a signature of life, most likely, because it has to be generated by some process that keeps renewing it. So if we find oxygen in the atmosphere of another planet, that will be a very good indicator that there could well be life there, because there are not many non-biological processes that keep generating oxygen and keeping it in the atmosphere of a planet. So that's the reason Mars hasn't got oxygen very much, is there's no process to generate it, and it's all reacted into the rocks. So, what other questions have we got? I'm from America. This is Mihoko, and I'm wondering, how does astronomical societies cooperate internationally, if at all? Yeah, they do cooperate internationally. I've been to many conferences, international conferences of both amateur and professional astronomers, and there is a thing called the International Astronomical Union, which is responsible for naming objects, newly discovered objects in the sky, and that's international. So I think that there is a lot of international cooperation between astronomers, and even in the amateur field. Even tonight, we've got a slightly international team here, and I get messages and images and correspondence constantly from amateur astronomers in all parts of the world. Any comments on that? Yeah.
Well, the internet has made astronomy just global, hasn't it? I mean, we're talking all the time to people like Chris Go in the Philippines and Agapios in Cyprus and people in Australia and South Africa all the time. So, yeah, and of course the States full of colleagues and friends now that we have all over the world.
Yeah, I think astronomy really is a model for people collaborating. Across language and cultural boundaries to advance science. And on that note, I will pass over to Crete, not Crete, sorry, Cyprus. To Cyprus. I was in roughly the right part of the world.
I was close enough.
Yes, I don't know why I said Crete, but Cyprus in the sunny Mediterranean, and Agapios is one of the world's leading planetary imagers, and he's been with us on several nights already in this series, and he's had fantastic skies, but he hasn't got such fantastic skies to date, I think. Well, what's happening there now?
Well, sadly, you're right. We don't have clear skies tonight, and it's quite a rare occasion, I have to be honest. But, you know, it happens here as well. It's currently raining outside. I did take a quick look at Mars just before we logged on, but I'd say I wouldn't feel safe setting up a telescope with, you know, storms coming and going. So although I can't show you live images tonight, I've prepared a very short presentation on what it's like to be here in Cyprus and observe and take images. And I'd like to show you that.
Yes, please.
Okay, so I will share my screen. I hope you can see that all right.
Yes, we can.
Okay. So I live here on the island of Cyprus. Cyprus is a small Mediterranean island on the far eastern corner of the Mediterranean Sea. The island is mostly flat in the center. We have a couple of large mountains, especially the Troodos mountain range in the center. You can see it there in this lovely satellite picture. The weather here is most of the time preferable and favorable for all kinds of astronomy, apart from tonight. And the climate is nice and warm. We don't have extreme winters, and it's mostly clear most of the year. So I've been doing astronomy here and astrophotography for about 15 years now. And I've had the chance to not only see many wonderful celestial events and capture them, but also share them. So this is what the top of the island looks like. This is near the peak of Mount Olympus here in Cyprus at roughly 6,000 feet. In the winter, it's always snow covered, and the skies up there are just brilliant, marvelous. Very dark, very clear, and oftentimes we do get good seeing conditions. Most of the time I like to observe at home. This is what my setup looks like. I just set up in the backyard. I use a Celestron C9¼ Schmidt Cassegrain on a German equatorial mount, and I have it on a rolling platform, as you can see. And this allows me to have the telescope set up all the time and ready to use at a moment's notice almost. I also use a couple of portable telescopes. Here on the left, you can see my 4-inch refractor, and on the right, my 3-inch refractor. Both of these are fantastic visual instruments. The 4-inch being an apochromatic telescope gives wonderful views, not only of the moon and planets, but also of deep sky objects. And on the right, my old faithful, as I call it, a very old 3-inch achromatic refractor, which I still use to this day. And it's a really nice telescope for observing the moon and eclipses and other celestial vistas. Oftentimes I have a chance to go up the mountain and enjoy these beautiful clear dark skies that we have here. This is from a very recent excursion. It's really one of my favorite aspects of doing astronomy here in Cyprus, the fact that you can go up to the mountain and be in nature and get to enjoy this beautiful night sky from such a wonderful setting that we have here. And to show you some images, I really love observing the solar system, starting with the sun. Some white light images. These are taken through my 3-inch refractor using a white light solar filter. And I think it's pretty important to note that one must never attempt to view the sun unless one is using safe solar filters. The sun now is not really active. We've only just had a few sunspots, I think, recently. But there were times when the sun was really active, as was the case here. In 2014, we had an incredible cluster of sunspots. I think it was mentioned at the time that the main cluster there was about the size of the planet Jupiter. And I was able to observe this over many days, as you can see, and capture these successive images. It really was one of my most memorable sessions with observing the sun. The moon, of course, another favorite. It's a great pleasure to be able to take pictures of the moon with very simple methods, even with a simple DSLR camera or even a smartphone today. Even smartphones have really good cameras and can take really impressive images over a simple telescope. This is a mosaic I did a few years ago, many panels stitched together, showing the intricate detail of the lunar surface. And some more high resolution views through the C9¼ telescope, the crater Plato and the area around it. You can see some small craterlets picking out in Plato. Crater Clavius and Plato again in another view here. It just goes to show that the moon has just so many different features one can observe visually as well as take pictures of. Eclipses again, another favorite, being able to see the moon cross in front of the sun. I think you can just barely see there the lunar relief showing on the silhouette here. These were taken recently on the June 21st solar eclipse, which we got to observe here from the island. And I really enjoy being able to take images throughout the entire event from start to end. A penumbral lunar eclipse. This one was in January. I took these with the 3-inch refractor, even though a penumbral eclipse is not really obvious to the untrained eye. If you attach a camera to a telescope and take a shot, it's really evident. You can quite clearly see the shading going on the moon, even if you can't see it with your naked eyes. A total lunar eclipse. This, I think, was probably the dimmest I've seen the moon during a total lunar eclipse. Just 3 panels showing the different phases of the totality. And transits. This was transit of Venus taken in 2012 using a 3-inch apochromatic refractor. This was an unforgettable experience. We got to see the exit of Venus from the solar disk just as the sun was rising. It was a sunrise I will never forget. We got to see the sun rise with a chunk missing. Quite impressive. And the recent transit of the planet Mercury, this one in 2016, and this one in 2019. We had beautiful weather for this one, and we got treated to an impressive sunset as well. The recent comet, one of the most impressive sights to the naked eye. It's definitely was the brightest comet that I remember. We got to observe this quite intensively over many nights, and it really was one event where we got to get a lot of people out and observe by posting, information about the comet and where to observe it. We got a lot of people to go up the mountain and really take in this beautiful sight. I did manage to go up to the mountain and take a few pictures of the comet. These were taken with a very old 50 millimeter lens, and they give it sort of a vintage look. But it really was a really impressive sight. And on to planetary work. This is the planet Venus. This is a false color composition taken with ultraviolet and infrared filters. And Jupiter. Jupiter is the object that I've probably observed and imaged the most over the years. It's a very impressive, a very dramatic object to observe through the telescope. There's just so many things happening on the planet, not only on the planet itself, but with the moons as well. And using the C9 telescope, you can pick out surface features on the moon as well when the seeing is good. Over a long period of time, you can capture different faces of the planet. For example, here we have successive images showing the Great Red Spot rotating into view. Another shot with the moons Ganymede and Callisto showing surface details. And I'm also a very big fan of producing animations of the planets. This is the reason why I prefer using a color camera, contrary to many others. Because when you use a color camera and you image over an extended period of time, these are very easy to produce. In this example, we have the moon Io going into eclipse, hiding in the shadow of Jupiter. And when I process the individual frames, you can see here on the left, you can see how gradually Io lost its color. And on the last frame here, you can see it being partially obscured by the shadow of Jupiter. This was in 2016. And here, a double shadow transit, a double moon and double shadow transit. We have the moons Io and Europa crossing the Jovian disk and their shadows as well. And if you look closely, you'll see how the relative distances between the moons change. The distances of the shadows change, the relative positions of the shadows on the planet change as well. And this was a really long session. These were images taken over the period of 4 hours. And again, a testament to just how dynamic the planets can be. Saturn as well, perhaps my best result on Saturn to date. This is the one target that's giving me a very difficult time. I can't seem to be able to get the ideal conditions for this target, with this being perhaps my best so far. You can probably make out some bright storms on the pole here. And more recently, the planet Mars. This was taken in September of this year, an animation covering about 3 hours of consecutive images showing the slow rotation of the planet. This was perhaps the night when I had the best conditions that I remember ever. A very, very long episode of very good seeing without any graduation, as you can see in the animation, and one that I hope I have another chance to get before this apparition is over. And a small project that I'm working on for this apparition of Mars, trying to complete as many panels as possible to show the difference in the appearance of the planet, the apparent size of the planet, the many different faces of Mars, as well as any obvious changes on the planet, such as the retreat of the South Polar Cap, and now with the upcoming dust storm, which is definitely going to change the appearance of the planet. So these were just a few images. And if I may, I'd like to just quickly mention my affiliation. I'm an astronomy guide at the 1010 Observatory here in downtown Nicosia. If you're ever in Nicosia or if anybody's watching, we have a public observatory here that the people can visit, and we do astronomy nights and outreach events. We also have school visits and a lot of activities for the kids. They get a chance to look through our 14-inch telescope, and we also have a nice meteorite exhibit, some astrophotography, and we also do some workshops and presentations as well. So that's it from me. Thank you so much.
Thank you very much, Agapios, for showing us all that, and thank you very much for your contributions this week, which have been absolutely invaluable to have your Mediterranean station there having completely different weather from what we have in the UK. So really, really big contribution. Well, we've run out of time today. So say thank you to Eric in Scotland and to Ian Sharp in Sussex. And tomorrow there will be a slightly different team, or completely different team of practical astronomers at 7 p.m. on Saturday. Tomorrow the show will be presented by Robin Scagel, and he will have as his panelist James Dawson in Nottinghamshire, and somebody from the Kielder Observatory in Northumberland, which we were joking it's always cloudy there, but maybe they'll come up trumps and maybe they'll be clear. And we have Ian Lorries in Essex and David Strange in Devon. So some old and some new faces if you've been following this over the last week. So I'll say thank you very much to Lucinda for expertly managing the audio and video again. And we'll catch up with you tomorrow or on Sunday.
Thank you so much, everybody. It was a fantastic evening, and Kielder was with us yesterday, and they did show us Mars. It was fantastic. So, but your evening was just as wonderful. Thank you all for being with us. Everyone say goodbye, and thank you. Have a good night, everybody.